everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Physics Chapter Work, Energy, Power. We have discussed about work, energy and power, the units and measurement in the first session. In the second session, we have discussed about the different forms of energy. Continuation will be done in today's class. Hope you all are ready. Let's begin. Different forms of energy. Nature has provided us with different forms of energy and we know that sun is the ultimate source of energy. The different forms of energy, we will be discussing 12 different forms of energy. The first one is solar energy. Second, heat or radiant energy. Third, light energy. Fourth, chemical or fuel energy. Fifth, hydro energy. And sixth, electrical energy. Okay. Then we have nuclear energy, geothermal energy, wind energy, sound energy, magnetic energy and mechanical energy. We will be discussing in detail all these 12 forms of energy and the conversion of one form of energy into other. Okay. First one is the solar energy. Solar energy is sun's energy. Energy that we get from sun is called solar energy. Okay. The energy radiated out by the sun is called solar energy. This energy is not uniformly available. At all times it is not available. During night time it is not available. So it cannot be used directly. It is in a diffused form. Therefore, we can use solar panels, solar furnaces and solar cells to make use of solar energy. Solar cells are semiconducting devices. So, it is actually less efficient because solar cells are very small devices. It can convert the solar energy into electrical energy but very less effective. Okay. These solar cells can be together form a solar panel. So, in a solar panel there is a dark black plane on which the solar energy, sun's energy can be focused and can be made into use. Then you have solar furnaces. So solar furnaces will be looking somewhat like this. There is a mirror, a concave mirror using which the solar energy can be focused. This focused energy can be used to heat water. Okay, the water in the surface can be heated by focusing the solar energy, sun's energy. That heat which is focused can be used to heat the water. Okay, the steam which is liberated can also be used to run the turbines and generators can be made to work. Understood what is solar energy? Got an idea about solar energy? Second is heat energy. It is also called thermal energy. You know what is heat? You know the difference between a hot object and a cold object. Energy can be made to flow from a hot object to a cold object. Okay, when you pour this hot water to the cold water and there is an energy transfer. Then the energy that is released on burning coal, oil, wood and gas is called heat energy. Okay, when you burn coal, what is happening? You are getting heat. Okay, this is a source of heat energy. Then steam engines, they work under the principle of heat energy. That is, they are using heat energy to work. When you burn wood, what is happening? You are obtaining heat energy, right? Firewood, you know what is happening there? While burning firewood, that is, you are supplying heat and you are getting heat energy, right? So this is a basic idea about heat energy. When you burn something, you will be getting heat energy. So sun is again the ultimate source of heat energy as well. Sun is a source of heat energy. The heat energy from the sun can be used for various purposes. Okay, that is about heat energy. The third one is light energy. Why do we need light? You can see me just because there is light. If I switch off the light, what happens? You won't be able to see me, right? So to see an object, you need light. Sun is again the source of light energy. Okay, light energy, it is a form of energy in the presence of which other objects are seen. How is an object seen? For example, why does leaves appear green in color? Because sun's energy is taken by the leaves, all other colors gets absorbed. That is, in Vibgyor, violet, indigo, blue, yellow, orange, red, all these colors gets absorbed, only the green color gets reflected. Okay, if some other object, a red color object, it is appearing red because all other colors gets absorbed, only the red color gets reflected. Okay, and our eyes will be able to see only the reflected colors. Clear? So this is why a leaf appears green in color. Now in the case of photosynthesis, what is happening? In presence of sunlight, green plants prepare food. Okay, this food is stored in the plants in the form of glucose. Here using carbon dioxide and water, green plants, they take sunlight, that is the light energy, to prepare food. Okay, so this is a process in which light energy is used. Then electric bulb. In electric bulb there is light energy. It is a source of light energy. Anything else? A candle. A candle. Then kerosene lamp. Kerosene lamp is an example. Next, torch. Torch is an example. So these are examples where you have light energy, where you get light energy. These are sources of light energy. Okay, fourth one is chemical energy. It is also called fuel energy. The energy possessed by fossil fuels such as coal, petroleum and natural gas is called chemical energy. That is in presence of oxygen when you burn a fuel. Okay, examples of fuel. Here we have coal, petroleum and natural gas. Are there any other examples? You have LPG. LPG is a fuel. Then CNG is a fuel. Biogas. This is a fuel. What else? Wood is a fuel. Okay. So when these fuels are burned in the presence of oxygen, a minimum temperature should also be given. For example, if you want to burn a paper, by burning a paper you are getting heat energy and light energy. You have to supply heat. Like using a candle, you can burn a paper. You are supplying a minimum amount of heat. Okay. So oxygen, in the presence of oxygen, the reaction is combustion reaction is happening. So in presence of oxygen, when fuels are burned, you will be getting energy. Okay. This type of energy is fuel energy or chemical energy. When you have food, the food we eat contains chemical energy, which it gives us chemical energy. Now in case of plants, what is happening? During the process of photosynthesis, using solar energy, plants are preparing their food. The food is stored in the form of glucose. Glucose is a chemical. Okay. In case of battery, energy is stored in the form of chemical energy. So this is what a chemical energy is. These fuels can be in solid state, in liquid state or in the gaseous states. Okay. Next is hydro energy. What does hydro mean? Hydro. What is hydro? Hydro means it is related to water. That is, energy from water is called hydro energy. The energy possessed by fast moving water. What does fast moving water mean? Is called hydro energy. Now in case of a dam, you know, water is stored at heights. Okay, there is potential energy. When energy is stored at heights, there is potential energy. When the water starts moving, what happens? This potential energy gets converted into kinetic energy. Yes, kinetic energy is energy in motion. Energy due to motion is called kinetic energy. So when water is moving fast, it is having kinetic energy. This kinetic energy helps the turbines to rotate and the generators helps to produce electricity or some other sources of energy. So this is what hydro energy is. Energy that is related to water. The next one is electrical energy. We all are familiar with electrons. We know what are charges. Okay. Energy that is related to charges and electrons is called electrical energy. When two bodies are rubbed together, they get charged due to the movement of free electrons from one body to the other body. So they possess electrical energy. Now consider an example. I'll show you a simple experiment. Here we have small pieces of paper. I have taken small pieces of paper and I have a plastic object, maybe a scale or a pen. When you rub this pen on dry hair, okay, I am rubbing it on my dry hair. When I rub, what happens? The pen is getting charged. Okay, when a body gets charged, there will be flow of electrons. Now let's see what is going to happen. And I am going to keep it near this paper. The paper will start clinging to this pen. So what has happened? The charged pen helped the paper to cling over it. Okay, so here the energy is electrical energy. The pen is having an electrical energy due to the flow of electrons. You know, in case of a battery, what is happening? A battery has a positive and negative terminal, that is positive electrode and a negative electrode. When electricity flows, what is happening in a circuit? From the negative terminal to the positive terminal is where electric energy flows, that is electrons flow. In the opposite direction, there will be current. Okay, so electric energy, how do we get electric energy? To run any device, in our home, electrical appliance, we need electrical energy. Where do we get it from? It is from the power plants. So from power plants we are getting electrical energy through cables and lines. Okay, so this is a basic idea about electrical energy. We need electrical energy in our daily life. Seventh one is nuclear energy. Nuclear is a word that is related to nuclear bombs or atom bombs. You all might have heard about atom bombs. Okay, in atom bombs, energy related with atom bombs or nuclear bombs is nuclear energy. It is otherwise called atomic energy. Let's see what it is. The energy released due to loss in mass during the processes of nuclear fission and fusion is called nuclear or atomic energy. What is fission and fusion? When a nucleus breaks into, it is a breaking process, breaks into two smaller nucleus, we call this reaction as fission, nuclear fission reaction. And when it combines to form a single nucleus, two smaller nucleus combines to form a single nucleus, this reaction is called fusion reaction. Here it is breaking and here it is fusing, that is combining. Okay, in case of nuclear reactors and in case of atom bomb, the energy involved is nuclear energy. In case of nuclear reactors, it is used for the constructive purposes. Okay, for constructive purpose, energy is being used. That is, in nuclear reactors, the nuclear energy is getting converted into electrical energy and other forms of energy. For useful purposes it is. Okay, when it comes to atom bomb or nuclear bomb, it is used for destructive purposes. Here the nuclear bombs are used for destructive purposes. Always the energy will be in the form of, that is, it will obey Einstein's mass energy relation, which is E is equal to mc square. Just see here, the energy released due to loss in mass. When mass is lost, it is getting converted into energy according to E is equal to mc square. E is energy, m is mass and c is the speed of light. Okay, this is about nuclear energy. Next is geothermal energy. From the word itself it is clear. Geo means earth, related to earth. Okay, thermal means heat. Geothermal means related to earth and heat. Okay, the energy released in nuclear disintegrations in the interior of earth gets stored deep inside the earth and is called geothermal energy. Take this case here. Due to nuclear disintegration, what happens is the underground water, it gets heated up. Okay, the hot water then gets converted to steam and this steam can be trapped, can be drilled out and made to rotate, made the generators to work, and this generators can then produce electrical energy. This is a process, that is, a steam is being used. Thermal, steam is related to heat. Thermal, okay, underground, that is related to earth. So this energy is called geothermal energy. Next one is wind energy. Energy that is related to wind. Okay, the energy possessed by fast moving wind is called wind energy. So when wind hits this windmill, what happens? It starts rotating. Because of this wind, fast moving wind, the windmill starts rotating. There is mechanical energy and it helps to rotate the turbines and produce electrical energy. Okay, in a large scale this process is being used. That is, windmill is used to produce electrical energy. Wind energy is getting converted to electrical energy in the windmill. Clear? Sound energy. What is sound energy? A vibrating body possesses mechanical energy capable of producing sound energy. Take the case of a guitar or a violin. Here, when the violin string is striked, what happens? We have studied about vibrational energy. Okay, we studied about vibrational kinetic energy and vibrational energy. What was it? When a string that is supported with the rigid supports on both sides, when it is struck or plugged, what happens suddenly? It will have to and fro motions. It will go up and down. This to and fro motion is called vibration. Due to this vibration, due to this vibrational motion, what is happening? Vibrational motion, it is a form of mechanical energy. Vibrational motion, vibrational energy is a kinetic energy. Kinetic energy is a form of mechanical energy. Due to this motion, due to this mechanical energy, sound is being produced. Okay, this is called sound energy. Some other devices, can you give me examples? An electric bell. In an electric bell, what is happening? Sound energy is being produced. Then microphone is an example. Sound energy is getting produced. What else? A flute. That is, you can take Any musical instruments, right? In all these cases, sound energy is being produced. That is, our eardrum is vibrating and we hear the sound. Any other examples? Flute is an example, electric bell is an example, violin, guitar. Not just this, even other devices, that is when a vehicle is moving. When a vehicle is moving, what is happening? There is mechanical energy. We know there is mechanical energy. Even it produces sound. Okay, bullet. Okay, when bullets are moving in front of you, what is happening? There, sound energy is being produced. Okay, for undesirable or desirable purposes, there are sound energy produced. When you burn a cracker, what is happening? Light energy is there, heat energy is there, plus sound energy is also there. Yes, so sound energy, this is about sound energy. Next one is magnetic energy. The energy possessed by a magnet due to which it can attract iron fillings is called magnetic energy. Magnets we all are familiar with. What is a magnet? A magnet is a device which can attract metals to it. It can attract metal. There are permanent magnets and there are also other types of magnets. Okay, in case of permanent magnets or other types of magnet, what it is doing? It will be having north and south poles. Okay, they have opposite poles, north pole and south pole. We know that a magnet always exists in the form of dipoles. Magnetic monopoles cannot exist. When you cut a magnet, again you will be getting a new south pole and a north pole. Magnetic monopole never exists. What does this poles do? When like poles come together, what happens? That is, here the north pole of one magnet and the north pole of other magnet, when they are brought together, what happens? There will be repulsion. They will move away from each other. Moving away, this is called repulsion. Okay, when unlike poles are brought together, that is, north pole of one magnet and the south pole of other magnet is brought together, what happens? Yes, there is attraction. Okay, south pole and north pole will be attracted. They will stick together. If you have a magnet in your hand, okay, hold magnets in your hand, bar magnets in your hand. In that case, when you bring the opposite poles, that is unlike poles together, you can feel that attraction. When you bring the like poles together, when you bring the like poles close, what happens? You can feel the repulsion. There are different forms of magnets. That is like bar magnet, you have C magnet, U magnet, disc magnet, different types of magnet. That is when magnetic effect is there, the energy involved is the magnetic energy. Electromagnet is a device which produces magnetic energy using electricity. Okay. The last one is mechanical energy. Should I need to explain about mechanical energy? We have studied about mechanical energy in detail. Mechanical energy includes potential energy and kinetic energy. In the previous class, we have discussed what is potential energy, what is kinetic energy. Here, we have a boy who is standing with the ball. In this case, what energy he is having? Yes, he is having potential energy. The ball is held at a height. When the ball is held at a height, it is having potential energy due to its position. Energy possessed due to position is called potential energy. When it is dropped down, what is happening? The ball is moving. The ball is in motion. When there is motion, the ball is having velocity and it will be having kinetic energy. Okay. Mechanical energy is always the sum of potential energy and kinetic energy. Basic things. Okay. Now take this case. Here what is happening? We have explained this. When you have a bow and an arrow, when you pull the string, what happens? Energy, potential energy, elastic potential energy gets stored in it, and when released, the kinetic energy gained by the string due to its motion gets transferred to the arrow and the arrow starts moving. Okay, we have explained all these in detail in the previous class. So this is it. Mechanical energy is due to motion or state of rest. Okay. By now we have a clear idea about what are the different forms of energy. We have studied 12 different forms of energy. Sound energy, heat energy, light energy, electrical energy, mechanical energy, magnetic energy, etc. Now all this energy can be converted into different forms. The energy from sun, we can convert it into heat energy, light energy, electrical energy. all these energy, mechanical energy, into different forms. Now we are going to discuss about the conversion of energy. Okay, different forms of energy can be converted into other forms. Nuclear energy to solar energy, or chemical energy to mechanical energy, then electrical energy into magnetic energy, magnetic to electrical, vice versa is also possible. Then thermal energy into mechanical energy, mechanical to thermal energy. So we are going to discuss about the different conversion of energy. First one is conversion of mechanical energy to electrical energy. Generator is a very good example where mechanical energy is getting converted to electrical energy. Now consider this case. We know in dams what is happening? Water is stored at a height, that is there we have potential energy because of position. Energy possessed by a body due to its position is called potential energy. So when water is stored at a height, it has potential energy. When it starts flowing, what happens is potential energy will get converted to kinetic energy. Kinetic energy is energy that is related to motion. When a body is in motion, there is kinetic energy. Now this kinetic energy, when water falls with very great force, it can help the rotation of turbines and can produce electricity. So this is the working, that is potential energy and kinetic energy are forms of mechanical energy. Here the mechanical energy is being converted to electric energy. When the water flows, there is kinetic energy. This kinetic energy helps in the rotation of turbines and they can produce electricity. Why do we use a generator? Where do we use a generator? Generator is used when you need electricity, right? So here when the turbines rotate, in case of generators, the armature coil rotates, the mechanical energy. During rotation, there is mechanical energy. This mechanical energy gets converted into electrical energy. Clear? Next is just the opposite, that is conversion of electrical energy into mechanical energy. Now consider these devices, that is a blender or a mixer grinder, then electric fan, washing machine, all these have got motors. Okay, these motors are devices which converts electrical energy into mechanical energy. Here what is happening is when electric current is passed, in presence of magnetic field, the coil here will start rotating. There will be a torque experienced by it. Okay, you have studied about torque. Force into perpendicular displacement is torque. Due to this torque, there is a rotation. This rotation, that is rotation is a motion. Okay, there is mechanical energy produced. Using electricity in presence of magnetic field, what is produced? Mechanical energy is produced. This motor, here the shaft, it starts rotating, and due to this rotation, all these devices works under this principle. Okay, due to this rotation, the wings of fan can rotate. The blender, in this blender, it can start working. Now the washing machine, it starts working because of this motor. Here what is happening? Electrical energy is getting converted into mechanical energy. Okay, next is electrical energy conversion into heat energy. Where do we have heat energy? Consider these devices. Here we have a microwave oven, you have a toaster, then you have an iron box. All these objects, all these devices gives heat. Where do we get this heat from? It is from the electrical energy. So when you plug in this and on the switch, what is happening? The devices starts getting heated. Okay, in all these things there will be a filament or a resistance wire. So this filament, usually it will be a tungsten filament because resistance should be high or it will start melting. So your tungsten filament will be used. This tungsten filament, it will heat, and this heat will be used to heat the devices. Okay, for cooking purpose you will be using a microwave oven. So what is the principle here? Electrical energy supplied is getting converted into heat energy, and this heat energy gets transferred to the food item and the food item will get cooked. Okay, again in case of toasters, the same thing is happening. Electric iron box, same thing is happening. When you plug in and on the switch, what is happening? The device starts getting heated, and this heated device can be used to iron the clothes. Okay, next is the conversion of electrical energy to sound energy. This is mainly in case of loudspeakers. Okay, in case of loudspeakers, what is happening? From the microphone, electrical signals are taken. This electrical signals flows through the loudspeakers and they convert it into sound energy. That is, high volume sound energy is produced in case. Electric bell. Your school bell, how does it work? School bell, how does it work? Here electrical energy is given. This electrical energy causes vibration in the bell and the bell rings. Okay. Sound energy is produced. Okay. In case of electric bell, electrical energy is getting converted into sound energy. Vibrations are created and it is getting converted into sound energy. Loudspeakers and electric bells are examples of conversion of electrical energy into sound energy. Okay. Next is converting sound energy to electric energy. How does a microphone work? What is happening in case of a microphone? Why do we use a microphone? Here sound energy is given. Okay. They can produce electrical signals. Electrical signals can be produced by the microphone. Okay. When I tap a mic, what happens? I can see the fluctuations, that is the variation of electrical signals can be seen. So in case of microphone, what is happening? The sound energy is getting converted into electrical energy. This electrical energy variations can be noted, and this electrical energy using loudspeaker can again convert the electrical signals into sound energy. Okay. Next is a conversion of electrical energy to chemical energy. How does your mobile get charged? Mobile phone. Take the case of mobile phone. How is it getting charged? What is happening? When you keep it for charging, after some time it will be showing 100%. What is happening here? You are supplying electrical energy. This electrical energy gets stored in the form of chemical energy in a battery. So initially this is how it looks like. Okay. Your phone battery, it will be showing 2% or 3%. You will go plug it in. On the switch, what happens? After some times it becomes 20%, 30%, 40%, maybe in 2 or 3 hours it will be showing 100%. Here what is happening? The electrical energy that is being supplied. What happens to the electrical energy? It gets stored in the battery in the form of chemical energy. Okay. Here electrical energy is getting converted into chemical energy. In a battery, electrical energy gets converted into chemical energy. Okay. Chemical energy conversion to electrical energy. Take the case of a battery. Battery has positive and negative terminals. You need a device to work. For example, you are connecting this battery to a circuit. In a circuit, you are having connecting the battery. Then you have a key. Okay. Let's say you have an electric bulb. So here what happens? When you on the switch or put the key here, electron starts flowing. Electron starts flowing from the negative terminal to the positive terminal. Okay, it starts flowing from the negative terminal to positive terminal. Here inside the battery, energy was stored in the form of chemical energy. Okay, it is stored in the form of chemical energy. When connected to the circuit and the switch is given or the key is given, what happens? This energy gets converted into what form of energy? Electrical energy. Okay, due to the flow of electrons. In the opposite direction, there will be current flow. In which direction electrons flow? In the opposite direction, there will be current flow. Okay, here this is happening. And this electrical energy can help the bulb light. Chemical energy conversion into electrical energy. Inside a battery, chemical energy is stored. Once connected to the circuit and key is given, what happens? Electron starts flowing. Due to the flow of electron, what is happening? Electrical energy is being created. Next is conversion of chemical energy to light energy. Take the case of a candle. In candle, how is light being produced? It contains wax. Okay, wax is a chemical. So when you burn this candle, what is happening? The wax is acting. The chemical in the wax is helping to produce light energy. Okay. Next, in case of a kerosene lamp, same thing is happening. There is oil and this oil will be helping to convert chemical energy to light energy. You might be heard about the fireflies. They can produce light on their own. What is happening? This is an example of a chemical change. Here again, chemical energy is getting converted to light energy. They have a enzyme in their body called luciferin, which converts the chemical energy to light energy. Okay. It is called bioluminescence. This effect is called bioluminescence. Next is converting light energy to chemical energy. A very simple example we have, which is photosynthesis. We have been studying about photosynthesis from very smaller classes. Here what is photosynthesis? Photosynthesis is a process of preparation of food by green plants using water, carbon dioxide and chlorophyll in the presence of sunlight. Sunlight is a source, that is, sunlight is a source of light energy. Sun is a source of light energy. Here the green plants are using the light energy and converting into chemical energy. What is the chemical? Food is the chemical here. Okay, food is the chemical. Here the process is, here what is happening? Carbon dioxide plus water in the presence of sunlight and chlorophyll gets converted to glucose. Glucose is the form in which food is getting stored in green plants. Okay, so here light energy is getting converted to chemical energy. The chemical is glucose or the food we eat. Okay. Next is electrical energy to light energy. In case of an electric bulb, how does an electric bulb glow? What is happening? A tube light or a CFL bulb, how does it glow? Electrical energy is getting converted to light energy. So when you on the switch, suddenly the light glows, right? What is happening here? When you connect it, or if you take a small LED bulb, it is taken and connected to a circuit. That is, you have a battery. Battery is a source of electrical energy. Battery will be having positive and negative terminals. Then you have a switch or a plug key connecting it to a bulb. This is how you represent a bulb. You have an LED bulb. What happens? When the key is in the on state, what happens? Electron starts flowing in this direction and the current flows in the opposite direction. When a current flows, there is electrical energy. Due to this electrical energy, what is happening? Yes, the bulb will start glowing. The bulb will glow. Okay, this is the process of conversion of electrical energy to light energy. In case of an electric bulb, electrical energy is getting converted to light energy. Some other example, LED bulb is an example. Then you have CFL bulbs, tube light, torch lights. In torch lights, you will be using batteries. So here the battery, what is it doing? It is helping to convert the electrical energy to light energy. So all these are example of converting electrical energy to light energy. Next, light energy getting converted to electrical energy. In case of the solar panels, we have discussed about solar panels and photoelectric cells, then solar cells. Here what is happening? From sun, light energy is being absorbed. That is, both heat and light is being absorbed. Here the light energy is being absorbed and it is getting converted into electrical energy. Next is conversion of chemical energy into heat energy. Consider these examples. Burning of crackers, bursting crackers. What is happening? Crackers contains chemicals. Okay, when you burst crackers, you have heat energy produced. Okay, not just heat energy, there is sound energy and light energy also produced. Here we have taken this as an example of conversion of chemical energy into heat energy. Bursting crackers is an example. Then burning of fossil fuels like coal, petroleum, etc. What is happening? When you burn wood, even when you burn wood, what is happening? Due to the combustion, in the presence of oxygen, burning process is happening. That is, a chemical in coal is getting converted into heat energy. It is producing heat energy. Same with the case with candle. We have discussed it for the conversion of chemical energy to light energy. Here not just light but heat is also being produced. When you touch the flame, what happens? Your hands will get burnt. What is the reason? Here heat is being produced. Okay. So in case of candle, we have both heat energy and light energy. Here we have studying this as an example of chemical energy conversion to heat energy. In case of steam engine, in steam engine what is happening? Steam, it is heat. Okay, this heat is being used for the kinetic energy. That is, the piston should move. Okay, this piston should rotate. Only then the steam engine can move forward. So using the steam, that is heat, the pistons are able to move. That is, rotation is being created. There is motion, there is kinetic energy, helps in the movement of the steam engine. In case of respiration, what is respiration? You are inhaling oxygen, aerobic respiration. You are inhaling oxygen. A chemical reaction is taking place and heat energy is being produced. Just keep your fingers in front of your nose. What is happening? You can feel a heat, right? When you exhale, you can feel the heat. You can feel it. Where does this heat comes from? Here the reaction is chemical energy is getting converted to heat energy. Heat energy, you can feel the heat energy as a byproduct of respiration. Okay, when you inhale the oxygen, there is a chemical reaction. You have studied about respiration in biology, so you may be knowing here what is happening in respiration. The chemical energy is getting converted into heat energy, and you can feel that heat energy. Next is conversion of chemical energy to mechanical energy. We know what is mechanical energy. We know what is chemical energy. In case of a car, why do we fill petrol or diesel in vehicles? What is the reason? These are fuels, right? These are fuels. Fuels are chemicals. Okay. So when they move, due to these chemicals, there is conversion of chemical energy to mechanical energy. When in motion, there is kinetic energy. So automobiles are moving just because when you fill them with fuel, chemicals, that is petrol and diesel, here the chemical energy is getting converted to mechanical energy. This is a process that is happening. Here it is kinetic energy because energy due to motion. Kinetic energy is a form of mechanical energy. Chemical energy conversion to mechanical energy is happening in case of automobiles. Next is conversion of electrical energy to magnetic energy. Here when you take the case of an electromagnet, you have heard about electromagnet. In case of electromagnet, electric energy is getting converted to magnetic energy. Using electricity, we are producing a magnet actually. Here we have an iron bar, a strong iron bar is used and a coil is wound over it. The other ends of the wire is connected to a battery. Okay. When electricity starts flowing through it, this device gets magnetized. And this is how electromagnet works. Okay, here electrical energy is getting converted into magnetic energy, and this device can then act as a magnet because it has gained magnetic properties. Using this iron nail, you can attract smaller objects, that is small metals, a safety pin, etc. can be attracted using this iron nail because it has changed into a magnet using the electric energy. Okay, so electrical energy conversion to magnetic energy, this is an example. Electromagnet is an example. Next, nuclear energy conversion to electrical energy. You know what a nucleus is? An atom contains a nucleus. Okay, an atom is made up of nucleus which is positively charged. It contains protons and neutrons. So inside the nucleus there is protons and neutrons, they are together called nucleons. Then there are electrons which are revolving around the nucleus in circular orbits. So this is a nucleus. You know what a nucleon is. So in case of nuclear energy, a nucleon can split into two smaller nucleons. Okay, in that process we call it fission. Fission means a breaking process. Then fusion, two nucleons combine together to form one nucleus. Okay, two nucleus combines to form combination, fusing. So this is fusion reaction. In case of a nuclear reactor, what is happening is the nuclear energy is being used to produce electrical energy. Okay, this is for a constructive purpose. Constructive purpose. This is a useful purpose, right? So we have also discussed about the atom bomb. For a destructive purpose, atom bomb is being used. So this is actually a useful purpose. Here nuclear energy can be used to produce electrical energy. You know how useful electrical energy is. For everything we need electrical energy, right? So electrical energy can be produced using nuclear energy in a nuclear reactor. Next is the conversion of mechanical energy to heat energy. We have taken this example here. Water is stored at heights. There is potential energy. When it starts flowing, what happens? It gets changed into kinetic energy. So when water is flowing, velocity is increasing, kinetic energy is increasing. So water falls from greater heights. When it reaches the bottom, here there is great amount of kinetic energy. A part of this kinetic energy gets converted to heat energy. Friction is created here. What is friction? When you rub your hands for some time, due to friction, there is heat produced. So if you rub your hands for some time, you can feel the heat, right? Why? Because here friction is created. Now, when this water falls on the moving parts of machine due to this heat, it starts working. So, this is what? An example for mechanical energy getting converted to heat energy. Okay, potential energy and kinetic energy are together called mechanical energy. One more important point to remember, whenever mechanical energy changes to other forms, it is always in the form of kinetic energy and not in the form of potential energy. We have considered the case of a dam. In dam, we know water is stored. There is potential energy, right? The potential energy cannot on its own produce other forms of energy. Let it be electrical energy or any other forms of energy, potential energy cannot be produced. This potential energy will first get converted into kinetic energy. Okay. So, the water that is stored at heights in a dam, what is happening? It starts flowing at a greater speeds. When it starts flowing, the water is in motion, there is velocity and there is kinetic energy. This kinetic energy can be used to rotate turbines, it can be converted to electrical energy and it can be converted to other forms of energy. So, only kinetic energy. First is a conversion of potential energy to kinetic energy. Mechanical energy should be in the form of kinetic energy. Only then other forms of energies can be produced. Potential energy on its own cannot produce other forms of energy. It should first get converted to kinetic energy. The energy stored first changes to kinetic energy and then kinetic energy changes to other forms. Okay. Just remember the example in which water is stored in dams. How? They can be used to produce electricity. The stored water has potential energy. It cannot produce electricity on its own. The energy stored should be first converted to potential. The energy stored, potential energy should be converted to kinetic energy first. Next one is degraded energy. While transforming energy from one form to another, desired form, the entire energy does not change into the desired form. A part of this energy changes to undesirable form or is lost to the surrounding as radiation and is thus of no use to us. Take the case of an electric bulb. Here, actually, what is the product? We are using electrical energy to get light energy. Is it only light energy that is being produced? When you touch the bulb, you can feel heat, which means heat energy is also being produced. Okay, using the electrical energy, heat energy and light energy both are produced. Heat energy is produced in a greater quantity. Do we need this heat energy? Can you use this heat energy anywhere? Heat energy that is produced in an electric bulb, can it be used? No, right? It is of no use, which means there is a wastage of energy. So, this is an example of a degraded energy. Next, take a case where a car is moving. When car is moving, what is the product here? A chemical energy should be converted into mechanical energy. Okay, mechanical energy, energy which is related to motion. Is it only the motion of car, motion of the automobile that is happening here? It is producing sound, right? Sound energy is being produced. Due to friction, there is heat energy being produced. Heat energy and sound energy, noise pollution is being produced. Are these of any use? We don't want heat energy. This is a waste of energy. Sound energy is not required. Just we need the body to move. Here we just need the automobile to move. There is a wastage of energy. This is again an example of degraded energy. Understood what degraded energy is? It is an undesirable form of energy. It is a wastage of energy. Okay, that's all for today. In today's class, we have discussed about the different forms of energy and we have studied the conversion of one form of energy to the other form. Hope you all enjoyed this session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.